Hello everyone. In this video we will talk about the third principle from solid principle, Liskov substitution principle, which known as LSP. The Liskov substitution principle is the third principle in solid design framework, and it's all about correct inheritance and behavioral consistency in object-oriented programming. What LSP say? Liskov substitution say objects of a superclass should be replaceable with objects of its subclasses without breaking the application. Which means I can substitute subclass with the superclass without breaking the correctness of the program. Okay? In simple terms, if you write a function that use a base class, you should be able to pass in any subclass and the function should still work as expected without any errors or unexpected behavior. Why is this important? Because improper inheritance can lead to fragile code where subclasses violate the expectations set by the parent classes. This breaks polymorphism and creates bugs that are hard to track. When we follow Liskov substitution principle, we will take the advantage of the first, you ensure that your subclasses are true extension of their base classes. Number 2, you make your code more reliable and easier to maintain. Number 3, you reduce the risk of unexpected behavior when using polymorphism. Let's deep dive into LSP with use cases. This is a bad use case for Liskov substitution. I have a class amphibian. Okay, this class contains two methods, one called swim for swimming and another function called walk for walking. Great. Right now, if I create a frog class that extend from amphibian, okay, so I have two methods, swim and walk, which exists inside the amphibian class. Okay, what is the problem with that? The amphibian class can extend to frog class because frog are amphibians. Okay, so no problem with that. So they can inherit the properties of the amphibian class without altering the logic and purpose of the class. But we cannot extend the amphibian class to a dolphin class. Why? Because dolphins only live in water, which implies that the walk method would be irrelevant to the dolphin class. So when you extend a class, if some of the properties of the initial class are not useful for the new classes you will create in the future, then the Liskov substitution principle in this case or in this scenario has been violated. Got it? So the solution to that is very simple. How? Just create interfaces that match the needs of the inheriting classes. In summary, what we have said, if a class inherit another class, okay, in very short and simple, it should do so in a manner that all the properties of the inherited class would remain relevant to its functionality. Okay, so now if you create a dolphin class extend from amphibian, okay, so you don't function walk not irrelevant to the dolphin class. Okay, let's apply and follow the Liskov substitution principle by we will create amphibian class. This amphibian class, okay, contain only the swim function, and we will create another class for walking. Its name walking amphibian. What we made now, we break the functionality, break down it, split the whole class to smaller classes but focused one. Okay, right now if I create a frog class extend from the amphibian, I will use a relevant method to it, which is swim. And if I create a dolphin class extend from the walking amphibian, right now I will use walk method. Okay, so every class, every subclass, okay, which is dolphin, should have all the properties or should have or do all functionalities exist in the parent class. Okay, this is the explanation of Liskov substitution principle. So, to make a conclusion, okay, to this explanation, the Liskov substitution principle very simply implies that when an instance of a class is passed or extended to another class, the inheriting class should have a use case for all the properties and behavior of the inherited class. Thanks for watching and see you next video.